So in today's video, we're going to look at our third type of transformation. We've already looked at reflections and translations, and now we're going to look at enlargements. So it very much speaks for itself in enlargement. What we're going to do is we're going to take a shape and make it bigger. We'll get stuck into the examples here, and we'll look at the different types of questions that we can be asked. The first one is to simply enlarge shape A by a scale factor of 2. So just to explain some things within the question. Scale factor. So the scale factor is how many times larger we make the length of each side, and that's important because I will do a separate video when we look at things like area after we've carried out an enlargement, or volume when we're talking about three-dimensional shapes. But when we're simply enlarging a 2D shape like this, so if we're enlarging by a scale factor of 2 in this case, then what we're doing is we're making the lengths of each side twice as long. Now, we haven't been asked to enlarge from what's known as a centre of enlargement, and we'll look at that in the next example and find out exactly what a centre of enlargement is and how that affects the answer to the question. So when we get a question as straightforward as this, when we just have to enlarge the shape itself, it doesn't matter where we place it. So the orientation stays the same, as in this part of the triangle will be pointing down, this will be pointing to the right. But it doesn't matter where on the page we actually draw the shape. We just have to make sure we have enough space. So rule of thumb that I always keep is that we are going to enlarge the horizontal and the vertical sides, and we'll do the diagonal side last because that means we can just join it up. To give myself plenty of space, I'm going to use this space in here. I'll start off by plotting a point for this corner. So here we start off for this corner, that is that corner there. So if I'm enlarging this side, which is 2 centimeters, I'm going 2 centimeters this way. So in the enlarged shape, instead of 2 centimeters, I go 4 centimeters. Now, of course, just like the other transformations, you should use a ruler for this. I'm, of course, using my left hand to film. So make sure to use a ruler when you're doing these types of questions. So that is that side enlarged. Now I'm going to enlarge this side. So the side going down the waist is 3 centimeters. So on the enlarged shape, it's going to go 1, 2, 3, 4, 5, 6. So we'll end up down to there. Okay. Again, of course, using a ruler and that. That means when we're dealing with, excuse me, the diagonal sides, all we have to do is then join this up. So to get this side here, again, that will be very tricky to measure because it's going across different squares. All we actually have to do is join this up. And again, we would use a ruler for that. So that is the enlarged shape. It's the same shape, just twice as large in terms of the lengths of each of the sides. Okay? And you can check that diagonal side with a ruler if you want. So if I was to measure that, that is 3.5 centimeters. And you can see that on the enlarged shape, it is 7 centimeters. Okay? Now, our second example looks at where we're asked to enlarge a shape, but this time using a centre of enlargement also. So this time we're dealing with a scale factor of 3. So that means the length of each side will be 3 times as long. But we have to enlarge from the given centre of enlargement. Sometimes they can ask you to plot the centre of enlargement as a coordinate, which we will look at in the third example. But this time the centre of enlargement is given as this point here. Okay? So this means that the enlarged shape ends up in a very specific position. Alright, so it's not like we can just draw this shape anywhere over here and say, okay, there's our enlarged shape. It has to end up in a very specific position. How I do this type of question is I count the squares from each point. So if I pick a point, right, and I'm always counting from the centre of enlargement. This point here on our triangle is 2 squares to the right of my centre of enlargement. So if it's a scale factor of 3, I'm multiplying those distances by 3. Okay, so instead of 2 squares from the centre of enlargement, I'm now going 6 squares. Okay, always counting and starting from the centre of enlargement. I'm now going 1, 2, 3, 4, 5, 6. So this point has moved from here to here. Now, if I was to pick my next point here, this is 1 down from my centre of enlargement. So it's a scale factor of 3. So I'm going 3 down. So going 1, 2, 3. So that moves from here to here. So those 2 points actually give me the diagonal side. Now, if I was to pick this side, okay, I actually already know, because if I was to draw, this point is given by the horizontal and the vertical from each of those points. I know it's going to end up here, but just to show you that, if I was to do the same for this point is 2 to the right and 1 down. So that means I will go 6 to the right and 3 down, just multiplying those distances by 3 again. So 1, 2, 3, 4, 5, 6, 6 to the right, 1, 2, 3, 3 down. That gives me my enlarged triangle. Okay, now again, using a ruler, of course, a way that we can always check that our shape is in the correct position. If we were to use the corresponding points on the original shape and an enlarged shape, so say for example the bottom right corner in each, and draw a line with a ruler straight through these 2 points, it would lead back to the centre of enlargement. Okay, and just to show you with the ruler, there you go. Okay, if I was to draw this line through there, it would lead back to my centre of enlargement, and that works for any point. So let's say the top right in each, so in the original, and again through there. So that's how I know that's actually in the right position. Okay, our third and final example, again dealing with enlargement. This time the only difference is we have to plot our centre of enlargement as a coordinate, and that's very easy to do. I've already made a video that you can have a look at in terms of plotting coordinates. Okay, so this time we're going to enlarge shape C here, and it's drawn, as you can see, on XY axis by a scale factor of 2 from centre of enlargement minus 1, 2. So minus 2, 1, 2 is going minus 1 across on the x-axis first, and then 2 up. Here is my centre of enlargement. So the first thing you do is plot your centre of enlargement. Okay, and then after that, it's simply counting the squares. Okay, so let's say I want to move this point first, so it is 1 square to the right of the centre of enlargement. So if it's a scale factor of 2, this 1 square, 1 times 2, which is 2, so I'm going 2 squares to the right. So this ends up here on top of this side. All right, say I want to enlarge this point, it's 1 up and 2 to the right. So 1 up and 2 to the right, doubling those distances becomes 2 up and 4 to the right. Okay, so 1, 2, 1, 2, 3, and 4. Okay, so there's my first 2 points plotted. This one is 1 down, 2 to the right, so I'm going 2 down and 4 to the right. 2, 2, 3, 4, so it ends up there. And again, just like our previous questions, don't worry about plotting on the X or Y axes or drawing over them or anything like that. Okay, so there we go. That is this point drawn. Okay, and that is our enlarged triangle. Okay, so I will plot, or I will give some questions for you to practice, and anything you need help with, just give me a shout.